As we have already completed our unit 1 part, the unit 2 part and unit 3 we have completed. So today we will start from the radiation chapter and we will see what are thermal radiation. So we will see what is the properties of your thermal radiation. So before going to this topic, so let me tell you about the transport phenomena. It includes the conduction process. First is your conduction process. Conduction means, so I will first give you one example. Suppose there are 5 persons, they are standing in a row. Suppose there are 5 persons, they are standing in a row and they have one book. The first particle or the first person, this first person has one book. Suppose he is the first person, this is second, third and fourth and fifth. So the first person has one book and he want to give this book to the person 5. The first process is that the first person will give this book to the second person, then the second will give it to the third person, then the third will give to the fourth, and finally the fourth will give to the fifth. So this is the process in which this book come to the second, then it will come to the third person, then to the fourth, and finally the book will reach to the person 5. So this is the process. It means that in case of solid, if I will give the example of a solid, it means that in case of solid the atoms are very closely packed. Since the atoms are very closely packed in nature, so if I will provide some heat at this end A, suppose this is end A and this is suppose end B, here I am providing some heat. So in this case the particle at this end A, they will get heated. On the application of the heat, they will get heated. Without disturbing their position, they will try to transmit that heat from its neighboring particle. Its neighboring particle means they will transfer this heat to its next particle, then to the next, then to the next, and finally this heat will transfer at this B end. So it means that without disturbing its position, without changing its position, this heat can reach to the one end to the other end. As in the case of this example, that is in case of this person, without disturbing their position, without disturbing the position of the first person, he sent to this book to the 2, then to the 3, then to the 4th, and finally this book will reach to the person 5. So this is the conduction process where the particle will not change its exact position. Otherwise we can say that it needs a medium, the heat will need a medium to travel from one end to the other end. So this process is called your conduction. So the next we will see the convection process. So the next we will see the convection process. Suppose this is your convection process. So what will happen to this convection? So in this convection process, so here also I am giving the same example, that is there are 5 persons are standing in a row. Now here also my condition is that the book is at this end, the first person has the book and he also want to give this book to the 5. Here in this case, in this second process, that is in this convection process, the person A, he will reach to the person 5. It means that he will change its position from the 1 and he will reach to the person 5 and then he will give this book to the person 5. It means that if I will give the example of the liquid, suppose this is a container containing any liquid, or suppose this is water, if I will supply some heat to this container, the molecules lying at this bottom part of this container, they will get heated, and at this condition when they get heated, they will become lighter and they will try to lift from its position, they will change its position from the, and otherwise I can say that they will move to the upper level. And this process, in this process you can see that the particle, they are present at this bottom of the container, they will change its position, and finally when the time elapses, then you can see that or you can feel that the water get boiled. So this process is called the convection, where the exact movement or the particle will exactly change its position. This process is called the convection. And finally we will give the example of your radiation, and the final process is called the radiation. In this radiation process, what will happen? Neither the particle 1 will changes its position, nor he will not its position means he will not travel from this end to the other end. Otherwise he will not give to the book to the second person, then to the third person. This will not going to happen. What will happen? The first person will directly throw this book to the 5. The person 1 will directly throw this book to the 5, and the person 5 will get this book. It means that in case of the radiation, during this process of radiation, the particle or the person A or the first person will not change his position, or I can say that they will not need any medium. So if I will give the example, that is, we receive the heat from the sun, which is millions of the kilometers, this is away from the earth. So after a few thousands kilometers, there is only the empty space with no material medium. If there is, the density doesn't exceed 1 or 2 molecules per cubic centimeter. So the presence of this matter of this density, it can be entirely ignored. Therefore, the process by which we receive the heat from the sun, it cannot be either conduction or the convection, which require an intervening material medium. So in the case of radiation, in this case, if we need an intervening medium, or we can say that is the material medium we need. So the process is termed as your radiation. That is, heat the travelling by the radiation is called the radiant heat or the thermal radiation. So during this process, the heat from the sun passes through the air around the earth, but the air is not heated. So the radiation can be called as, it can be defined as the transfer of heat from a hot body to a cooler body without appreciable heating of the intervening medium. It means that I cannot say that the intervening medium will not be heated when the thermal radiations falls on it or passes through it. In fact, the bodies may absorb radiant heat to be a greater or a lesser degree when the radiations fall on them or pass through them, and thereby they get heated to a greater or the lesser extent. So these are the 3 processes, that is conduction, convection and radiation, through which heat can travel from one part to the other part. So now we will see the properties of the thermal radiation. So the first of all, the properties of thermal radiation includes, the first property is the thermal radiation. It is an electromagnetic radiation. It is an electromagnetic radiation produced by the thermal motion of the charged particles in matter. So this is basically an electromagnetic radiation. It produced by the thermal motion of the charged particles in matter. And the next is, all bodies above the 0 Kelvin, it radiate thermal energy at all the temperatures, which increases with the increasing temperature. If we will increase the temperature, then the thermal energy of all the temperature, they will get increases. The next is, due to their electromagnetic nature, the thermal radiation, it travels through the vacuum with the velocity of light. And the next point is, the wavelength of the thermal radiation ranges from 8000 angstrom to 0.4 micrometer, that is, it lies in the infrared region of electromagnetic spectrum. The thermal radiation, it travels in a straight line. And the next is, the thermal radiation, they obey the laws of reflection and refraction, and it exhibits the phenomenon of interference, diffraction and the polarization like light. It means that, as in case of light, the phenomena of interference, diffraction and polarization, it satisfied this is also the same for the thermal radiation. They also obey this. The next is when the temperature of the body is more than the Kelvin is more than 0 Kelvin, the collision of the atoms, it causes the kinetic energy of the atoms to change. So with the increase of the temperature, as you know, when the temperature increases, the kinetic energy of the particle will get changes or increases. The next is the thermal radiations are unable to detected by the human eye. Next is the thermal radiations are detected by the bolometer, which depends on the change of the electrical resistance with the temperature, or the thermopile, which is a series of thermocouples. The next is the thermal radiation is not monochromatic. It is not monochromatic. It means that it comprises of continuous dispersion of photo energy. Now we will see some more properties, that is the nature of thermal radiation. It depends on the temperature. It means that at low temperature the body emits radiation of longer wavelength. At low temperature the longer wavelength radiation will happen. And the next is the thermal radiation. It consists of quanta or photons or the packet of energy, that is h nu, where h is the Planck's constant and nu is called the frequency of radiation. The next is the quantity of heat radiated per second. It depends on the nature of the emitting surface, its surface area and its temperature. The next is the continuous exchange of heat between a body and its surrounding continues till a dynamical thermal equilibrium is obtained between them and their temperatures become equal. So the continuous exchange of heat between body and surrounding, it continues till the dynamical thermal equilibrium is obtained between them and their temperatures become equal. Next is the thermal radiations produced heat when they are observed by a body. The next is the good observers are also called the good radiators and vice versa. You know this. And the next is the word radiation. It refers to the process in which the energy is emitted or transmitted by a body in space. It also refers to the energy itself which is being transmitted in space. And when the thermal radiations fall on a body, they are partly reflected, absorbed and transmitted. So the properties of the thermal radiation, what we have learned today is, the first of all what we have learned. So this thermal radiation, it travels through the empty space, or we can say that with the velocity of the light. The next is what? The thermal radiations like light, they travels in a straight line. And the next, the thermal radiation like light, they obey the inverse square law of distance. And the next, that is the thermal radiation is reflected and refracted like a light, or we can say that they obey, in case of light, they obey the laws of reflection, refraction, dispersion. So this is also the case of your radiation. The last one is the thermal radiation, which exhibits the phenomenon of interference, diffraction and the polarization like light. Interference, diffraction and the polarization of light. So this is the properties of thermal radiations which we have discussed today. So this is all for today, and in the next class we will see this the next, that is the black body radiation, etc. So thank you.